So, we are now, and some of you are going to love these and some of you are going to get really ticked about these. Alright, the area under this curve, this normal curve, the area under the curve represents 100%. 100% of the people under the curve. Okay? We are going to be doing something that's called the 68, 95, 99, 7 rule. 68, 95, 99, 7 rule. And we're going to do a ton of these. Okay? So, what that rule says is that if your mean is in the middle, which we talked about, if you go out one standard deviation in either direction, that represents 68% of the people. So if we jump one deviation either way, that's 68% of the people. If we jump two deviations in either direction, that represents 95% of the people. If we jump three deviations in either direction, that represents 99.7% of the people. And the whole curve is 100% of the people. So when I say 68, 95, 99, 7, 68 is one deviation in either direction. 95 is two deviations in either direction. 99.7 is three deviations in either direction. And we're going to do a ton of this. Okay? So we just finished 5-1. Now we're in 5-2. This is the picture that I kind of just drew on the sideboard. 100% is the entire curve. Standard deviation is our jumps, our spread. Okay? The mean is in the middle. One jump in either direction is 68. 95 is two jumps, and 99.7 is three jumps. So let's do a problem. Alright, this first problem says, and for everything that we're doing from now on, it's going to be a normal distribution. So it says, assume the resting pulse rates for individuals have a normal distribution. So that's telling me that it's going to look like this. The mean is 70, and the standard deviation is 15, because you're going to have to be able to draw the picture. So, first thing tells me that it's a normal distribution. The mean is 70, and the standard deviation is 15. So when I draw my other numbers, I'm going to be adding in increments of 15, and then I'm going to be subtracting in increments of 15. So 70 plus 15 is 85. 85 plus 15 is 100, and 100 plus 15 is 115. Then I'm going to subtract in increments of 15. 70 minus 15 is 55. 55 minus 15 is 40. 40 minus 15 is 25. So from the data that was given to me in the paragraph, I had to draw my picture. And I'm going to use that picture to solve all of my problems. So that paragraph is going to be used for every single one of these next few problems. We good? So this picture I have put down here. And I just said I added 15s and then I subtracted 15s. So I just took that picture and I copied and pasted it under every single one of my problems. We good? Okay. Percent less than 70. So first thing I'm going to do is I'm going to say my percent less than 70. So this is what I'm looking for. Y'all, if the whole thing is 100, the whole thing is 100, and it's symmetric, what percent does the yellow part represent? This part is going to be 50%. You with me? We good? That's my answer, 50%. 50% of the graph is shaded. Cool?
Yeah.
They're not all going to be this easy.
Oh.
Okay, let's look at the next one. Holtz is greater than 55. Holtz is greater than 55. These are like a puzzle. Now, when I'm doing this one, here's what I see. What is this piece? That piece is a 50. Now, a minute ago, we talked about if you go one deviation in either side. What was one deviation in either side?
68.
A 68. But do you agree that I don't need a whole 68? I only need a 68 cut in half. 68 is if I go one deviation in either direction. But I only need this slice. You with me? Because 50 was over here. So I've already counted this piece. So I only need this slice. So I only need a 68, but half of it. So I need a 68 cut in half, which will give me this piece, plus a 50. So a 68 cut in half is going to give me this piece, which is a 34. And then a 50 is going to give me this piece. So my answer is going to be 84%. All right, let's look at another one. Between 55 and 70. Do we see that this is screaming half of a 68? Because a whole 68 would be one deviation in either direction. So we don't want a whole 68. We want a 68 cut in half. So this is going to be a 34. All right, a little bit harder. I want to see what you can do with this one. There's more than one way to get it, but I want to see what you can do. That's how I want you to look at it. This one's tough, but I want to see what you can do on your own. My bad. TJ is here, Prisha's here, Amy is not here, Jacob is here, Bree's here, Sue's here, Aaron's here, Ashley's here, Tracy's here, Amber's not here, Jada, Amy is here. Sorry, I had a moment. Jada is not here. Tanya is here. Heather's here. Jessica's here. Brianna's here. Jarrett's here, Jamie's here, Carlita's here, and Calvin's here. You get an answer? Yeah. Mm. 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 The whole graph is 100%. You're the closest so far.
Alright, I got it.
Where are you? Look at you!
Wait, let me look. This one?
You cheat.
I did not. I just thought of it the other way. Okay, thank you.
We can do it as a dad. Alright. Easiest way to think of this one. Because it's kind of cattywampus. Because it's not a full 68 and it's not a full 95. So the way I thought of it is to say, okay, a normal curve is symmetric. It's kind of like a butterfly. Like butterfly wings. But the wing on the right is shorter than the wing on the left. So, this wing is a what? It's a 68 cut in half. Y'all with me? It's one deviation, which is a 68. But we're only doing one side of it, so it's a 68 cut in half. Now, this wing is two deviations, which is a 95 cut in half. So a 68 cut in half is a 34. A 95 cut in half is a 47.5. So together, your answer should be an 81.5. I know. I just tick you off, Ariel.
Because I did half and half, but I was doing a whole extra stuff along with it.
Now, you could have done like what is this? What is that?
That's 95.
That's a full 95. So you could have done a full 95, and then this is minus a 68. See, I can't even do that. Some people do it as a subtraction.
Well, my first thought was to divide it by 4 times it by 3.
No, because see, that wouldn't be a 34, because that chunk is smaller than this chunk. So not all of these chunks are 34, because as you go out, they get smaller. So 95 minus 68, somebody tell me what that is.
47.
47, thank you.
27.
Who? 27, thank you. So 27, 90 is going to tell me what these two pieces are. And if I divide that by 2, that's going to tell me what this piece is. So that's 13.5. So it's going to be a 95 minus a 13.5, which is going to give me 81.5. Which I just think is a lot harder.
Yeah.
So I look at it as a one wing minus or plus a two winger. So when I did this, it's a 68 divided by 2 and a 95 divided by 2. Let's look at another one.
How many questions about this one?
That's my bad.
All right. 70, we'll look at, see how many's on the exam. And I'm gonna show you an easier way how to do it in your calculator too. 70 and 100. So, when you look at this one, you have to ask yourself, if it involves one deviation is a 68 problem, two deviations is a 95 problem, or three deviations is a 99.7 problem. So, 70 to 100, do you see that's a twoer? So that means a 2 deviation is a 95 problem. Now, is it a whole 95 problem? It's a half of a 95 problem. So this is going to be a 95 cut in half. That's it. 95 cut in half. So the first thing you've got to say is how many jumps is it, and that'll tell you what you're using. So because it's a 2, that means it's a 95, but we don't need a whole 95. We need a 95 cut in half, which is a 47.5. Yay or nay?
Yep.
All right, let's look at some more. All right, those are the ones I just did. Yes. Right here. Those are the ones I just did. Yes. Okay, let's look at this one. I want you to try these two problems. Let me make it smaller so we can get it all on one page. Okay, you have the problem in the paragraph that you got to draw it and you got to do both problems. Oops, hold on. Let me delete this page. I'm thinking about it. And don't say anything. I'll come around and look. First thing we have to do is we have to draw it. So it says that it has a normal distribution, so that we know that it's gonna look like that. It says the mean is 50,000. So my mean in the middle is gonna be 50,000. Our standard deviation is 7,000, so that's the size of our jumps. So we're jumping in increments of 7,000. So we jump 3 to the left and we jump 3 to the right. So I'm gonna do to the left, to the right, to the right, to the right, and then I'm gonna do to the left, to the left, to the left. When I go to the right, I add. So it's gonna be 57,000. And then I add 7 more is 64,000. And then I add 7 more is gonna be 71,000. Then I'm gonna subtract 7,000. So subtract 7,000 is 43,000. What's 7 from that? 36,000 and 29,000. So that's what my picture is gonna look like. So I got all of that from the paragraph. Are we good with that part? Then I'm gonna take, and I can cheat, y'all can't, but I'm gonna take that picture and I'm gonna copy, that picture, already had it once. Gonna copy that picture. Let me just get rid of this because it wasn't all gathered. All right. And I am going to answer the first 2 questions. So this says at least $50,000. So if you have at least $50 in your pocket, that means you have 50,000 or more. So I want to know what percent are we talking about? 50%, because we're talking about half the curve. So the answer to the first one is 50%. Now, for the second one, what percent is between 43 and 64? So there's 43, and here is 64. Now, I've got to ask myself, how many jumps am I going? Well, 1 jump in either direction is a 68. 2 jumps in either direction is a 95. And 3 jumps in either direction is a 99.7. So I'm not a full jump, and I'm not 2 full jumps. I'm 1 jump to the right, and I'm 2 jumps to the left. So that's how I'm going to do it. I'm going to do 1 jump to the right and 2 jumps to the left. So this piece, scooch up. This piece is a 1 jumper, so that's going to be a 68, but I'm going to cut it in half because I'm only going to the right. This one is a 2 jumper, which because it's a 2 jumper, that's a 95, and I'm going to cut it in half because I'm only going one way. So a 68 cut in half, 68 divided by 2 is 34. A 95 cut in half is a 47.5. And when I add those together, I get an 81.5%. Feeling better? Now, in your homework, sometimes it will ask for percents, and that's what you would give them. Sometimes it will ask for relative frequency. Relative frequency means it just wants it as a decimal. So you would whoop it. So you would give them 0.815. So for this one, if it asks for the relative frequency, you would give them 0.50. So if it says what is the relative frequency, you would just whoop whoop. All right. Hold on. Let's do a couple more. Let's do, let me let you try A and B. A and B. A you can do, B's a little tougher. The directions, kind of skimmed them. It is a normal distribution with a mean of 60 and a standard deviation of 10. I want to know the percentage under the curve if the shaded region is between 40 and 80. And I want to know the percentage if the area is more than 70. You can do both of those. That second one's not hard. What was I saying? It's easy. Easy breezy. Husband will still be asleep. All right, we ready for this one? Okay, to draw the picture, we have a normal distribution, we have a mean of 60, we have a standard deviation of 10. So when we do 3 to the right and 3 to the left, we're counting in increments of 10. So it's 70, 80, 90, it's 50, 40, and 30. So for the first one, it says we want the percentage between 40 and 80. Well, y'all, you go, oh my gosh, it's 2 to the right, 2 to the left. This is a straight up 95. Good? All right, the next one. More than 70. More than 70. What'd y'all say for that one?
15.85.
Who?
15.85.
Okay,
14.775.